My name is Siddharth Mishra and I am going to teach you the physics for the preparation of your medical entrance exam or the engineering entrance exam. So dear students, I will start from the electrostatics chapter. Electrostatics means something which is static. Electricity in static position. Static means the it is not dynamic, not moving. Instead, being studied at some stationary point, stationary conditions. So guys, let's start the first chapter, which is termed as electrostatics. Means the electric charges which are stationary, not moving. This electrostatics represents the electric charges which are not moving but in a stationary condition. Okay, dear students, so let's start this chapter, first chapter, electrostatics of intermediate level, 11th and 12th. I'm going to prepare videos for you all for the whole subject. Okay, students, so let's start. So first topic is electric charge. First topic is electric charge. Electric charge. So what is the electric charge and what are the properties it is having? So let's define electric charge. Charge is the property associated with matter due to which it produces and experiences electrical and magnetic effects. Electrical and magnetic effects. So what is being said? So charge is the property associated with matter due to which it produces and experiences electrical and magnetic effects. And also it is known that every atom is electrically neutral. Every atom is electrically neutral. Containing as many electrons as the number of protons in the nucleus. It says that it is known that every atom is electrically neutral, means having equal number of electrons and protons, or having equal positive charge and equal negative charge. So it is known that every atom is electrically neutral, containing as many electrons as the number of protons, so that the total positive charge is equal to the total negative charge. That is why atom is neutral. And every atom is neutral. Every atom is having equal number of electrons and equal number of protons. Means total positive charge is equal to the total negative charge. That is why it becomes neutral. So it is known that every atom is electrically neutral, containing as many electrons as the number of protons in the nucleus. So also charged particles can be created by charged particles can be created by disturbing the neutrality of an atom. Neutrality means same number of positive charge and negative charge. Amount of the negative charge is equal to the amount of the positive charge. That is what is called neutrality. So loss of electrons so loss of electrons gives positive charge. Loss of electrons gives positive charge because in that case number of protons is greater than number of electrons, and gain of electrons gives negative charge. Because in that case number of electrons is greater than number of protons to a particle. So in charging the mass of the body changes. So in charging, the mass of the body changes as shown below. Suppose this is a rectangular shaped body. And it is positively charged. Positively charged means m prime less than m. M is the mass in the case when it is not charged, and m prime is the mass when it is charged. Positively charged means loss of electrons, so its mass decreases, so m prime is less than m. And in neutral condition, this is neutral, so its mass is m, and here it is negatively charged, so m double prime greater than m. So this first one is the positively charged, this is neutral, and this is negatively charged. So now also charges with the same electrical sign, charges with the same electrical sign repel each other, and charges with opposite electrical sign attract each other, attract each other. Means if this is a positive charge placed with another positive charge, then these two will repel, have tendency to move away. Repulsion. In opposite charges, like if the positive charge placed with another negative charge, then these two will attract, attraction. Also a charged body may attract a neutral body. Or an oppositely charged body but it always repels, but it always repels similarly charged body. Hence repulsion is a sure test of rectification. Hence repulsion is a sure test of electrification. Now let's see what is the unit and dimensional formula of the charge. Unit and dimensional formula So international system unit, it means SI, unit of charge. is ampere into second. Means is equal to coulomb. C. According to the formula, I is equal to Q by T. Q is the charge, T is the time, so I is the current. So I is equal to Q by T, charge flowing per second, that is current. So Q equals IT, I measured in ampere, T measured in seconds, and Q in coulomb. And also smaller units, smaller SI units are millicoulomb, means small m C, and microcoulomb. And in CGS unit system, CGS unit of charge is stat coulomb. Stat coulomb. Or electrostatic unit, ESU. Electromagnetic unit and electromagnetic unit of charge is ab coulomb. A small v coulomb. So what is the relation between all three units? 1 coulomb is equal to 3 into 10 to the power 9 stat coulomb. Stat coulomb is equal to 1 by 10 ab coulomb. And also the dimensional formula of charge. Dimensional formula since I is equal to Q by T, so Q is equal to I T. So dimensional formula in the big brackets, Q equals I measured in ampere, capital A, T time, capital T, and in big brackets. So Q equals 80 in big brackets. So this is the dimensional formula for charge. Now Also, the property of one property of charge is that charge is transferable. It can be transferred from one body to another. So charge is transferable. That is, it can be transferred from one body to the other. Also charge is associated with mass. That is, charge cannot exist without mass. But reverse is not true. It means that charge cannot exist without mass, but mass can exist without charge. Now, in case of charge, what is conserved? So, a charge is conserved. Charge is conserved. That is, it can neither be created, it can neither be created nor be destroyed. Also, charge is invariant. Charge is invariant. That is, it is independent of the velocity of charged particle. Also, every electric charge produces electric field. Magnetic field. And electromagnetic radiations. Electromagnetic radiations. So let me show this way. This is a positive charge. Its velocity is equal to 0. then it will produce electric field only. Also, if a charge moving with constant velocity it produces electric field and magnetic field. And also, if the charge is moving with varying velocity, means velocity vector v is not equal to a constant, then it produces electric field, magnetic field and radiation energy, radiates energy. So let me explain it to you. If any charge particle or charge is not moving but it is stationary, then it will produce electric field only. So, and also if the charge particle is moving with some constant velocity, then it will produce electric field and magnetic field both. And if the charge particle is moving or the charge is moving with non-constant velocity, varying velocity, then it will produce electric field, magnetic field, and it will also radiate energy. Okay, so now point charge. What is a point charge? Point charge. A finite size body may behave like a point charge. A point charge, point means what? Point is something which is not having any shape or size. That is called point geometrically. So point charge, a finite size body, a finite size body may behave like a point charge if it produces an inverse square electric field. An inverse square electric field. For example, an isolated charge sphere for example, an isolated charged sphere behave like a point charge at very large distance as well as at very small distance close to its surface, close to its surface. Now, charge on a conductor. Charge on a conductor. So, charge given to a conductor always resides on its outer surface. This is why both a solid and hollow conducting sphere of same outer radius will hold maximum equal charge. If surface is uniform, uniform means does not change with time or does not change with position. If surface is uniform, the charge distributes uniformly on the surface. And for irregular surface the distribution of charge the charge density is not uniform. The charge density is not uniform. It is maximum where the radius of the curvature is minimum. It is maximum where the radius of curvature is minimum. It is maximum where the radius of curvature is minimum and vice versa. Vice versa means it is maximum where the radius of curvature is minimum, and vice versa means it is minimum. It is maximum where the radius of curvature is minimum. So it is maximum where the radius of curvature is minimum, and it is minimum where the radius of curvature is maximum. This vice versa means that is charge density sigma, small sigma, proportional 1 upon r. Here r is the radius of curvature. R is the radius of curvature. Radius of curvature actually indicates how much is curved. So this is the reason. This is the reason why charges charge leaks from sharp points. Leaks from sharp points. Suppose this is a uniform and regular body, regular shape. So it will have charge uniformly and equally distributed over the entire surface. And if it is not uniform, having some shape like this, then it will have this way of charge distribution. So this is here. Now charge distribution. So charge distribution, it may be of two types. It may be of two types. Number one, discrete distribution of charge. Discrete distribution of charge. And the second one, continuous distribution of charge. So discrete distribution of charge, a system consisting of a system consisting of ultimate individual charges like Q1 is here, Q2 is here, Q3 is here, Q4 is here, and Q5 is here. This is discrete distribution of charge. And second one is the continuous distribution of charge. Continuous distribution of charge. So in continuous distribution of charge, an amount of charge an amount of charge distributes uniformly or non-uniformly on a body. It is of following three types. It is of following three types. First one, A. This is the linear distribution of charge. Linear distribution of charge. Charge on a line. Charge on a line for example, charged straight wire, circular charge ring, etc. Here lambda is the linear charge density. Lambda equal to charge by length. Charge by length. Lambda is linear charge density, means charge per unit length means in 1 unit of length how much charge is there, that will be depicted by lambda. So SI unit, SI international system unit is lambda. The SI unit of lambda is C by M, means coulomb per meter. and dimensional formula is equal to L inverse T A. Meter for length upon length, so it comes in the denominator, then it will become L minus 1, L to the power minus 1, and coulomb is Q equal to IT means A and T, I am in ampere, A, T time in means T. So now second one is the surface charge distribution. Surface charge distribution. Charge distribution on a surface charge distributed on a surface. For example, plain sheet of charge, plain sheet of charge, conducting sphere, conducting sphere, comma, conducting cylinder, conducting cylinder, etc. In this way. So charge density, surface charge density, sigma is equal to charge upon area. Where sigma is surface charge density. Its SI unit is coulomb per meter square. Dimensional formula is L to the power minus 2 A T. Now see volume charge density. Volume charge density. So volume charge density, when the charge distributes throughout the volume of the body. In the first one, the linear charge density, that comes when the charge is distributed over the total length of the body, whole length of the body. And the second one is the surface charge density, that comes when the charge is distributed over the entire surface of the body. And the volume charge density comes when the charge is distributed over the, throughout the whole volume of the body. Then volume charge density comes. Volume of the body, that is example gratia, charge on a dielectric sphere, etc. This is the dielectric sphere, rho charge density, so volume charge density rho is equal to charge upon volume. Rho is being the volume charge density. Then SI unit is Coulomb per meter cube. Dimensional formula is L to the power minus 3 TA. Coulomb's charge unit is 80 and m is meter cube, measured in length, so L minus 3. L to the power minus 3. Now, the another one property of charge is the quantization of charge. So what does it mean by, if the charge of an electron, how much is the charge of an electron? 1.6 into 10 to the power minus 19 Coulomb is taken as elementary unit, that is quanta of charge the charge on the body, the charge on any body will be some integral multiple of E, that is Q is equal to plus minus N E, where N is equal to 1, 2, 3 and so on. Also it means that charge on a body can never be plus minus 2 by 3 E comma plus minus 17.2 E or plus minus 10 to the power minus 5 E, etc. So now let us summarize the comparison between charge and mass. Comparison between charge and mass. So we are familiar with role of mass in gravitation, and role of charge in electromagnetism. So let's compare the two. Let's compare the two. Here in tabulated form charge and here mass. Number 1, electric charge can be positive, negative or zero. Number 1, mass of a body is always a positive quantity. Number 2, charge carried by a body does not depend upon velocity of the body. Number 2, in mass of a body increases with its velocity. Mass of a body increases with its velocity. According to m is equal to m naught m0 upon square root 1 minus v square by c square, where v is the velocity of the body, c is the speed of light, 3 into 10 to the power 8 meter per second, m0 is the rest mass. Rest mass means mass measured in the rest resting condition. Now let's the third one. Charge is quantized. Charge is quantized. Now it is not yet established. The quantization of mass is yet to be established, means it is under research. It is not yet decided. Number 4. Electric charge is always conserved. Electric charge is always conserved. Number 4. In mass is not conserved. Mass is not conserved, as it can be changed into energy and vice versa. Means energy can be changed into mass and mass can be changed into energy. So mass is not conserved. Now point number 5. Force between charges can be attractive or repulsive according as charges are unlike or like. Unlike means not same, like means same. And here number 0.5, the gravitational force between two masses is always attractive. So this is now the topic is completed. Now we have the whole notes. Now let's do the decoration. Now we are having it as the notes.